Section 7.7, Day 2, Geometric Sequences as Exponential Functions. Our essential question today is how do you make a table and a graph for a geometric sequence? Our first problem says make a sequence, table, graph, and equation to represent the situation. Evan paid $20,000 for his car 5 years ago. The car has depreciated in value by 7% each year. How much is his car worth now? I'm going to start out by making a sequence. Okay, so he paid $20,000 for his car. Because it's depreciating by 7%, I need to find the amount it depreciates. To do that, I multiply by 7% as a decimal, so 0.07. So 20,000 times 0.07 gives me a depreciation value of $1,400. So if I subtract that from the $20,000 that he paid for the car, after 1 year, the car is worth $18,600. Now, if I continue this pattern, so I multiply by 0.07 again, this time I get $1,302, then I subtract that, which gives me $17,298. And I can fit one more in my row. $1,210.86. So I'll subtract this one and then I'm going to round it. So $16,087. Okay, so there's my sequence. So then in my table, at time 0, the car was worth $20,000. After 1 year, $18,600. After 2 years, $17,298. And after 3 years, $16,087. So I have my sequence, I have my table. Now I need a graph and an equation. So I'm going to write the equation next and then draw the graph. So my equation, remember when you write your equation in function notation for a geometric sequence, it looks like this, where A is your initial value. So the car started out at $20,000. And B is what it's multiplied by each time. Now, I have to remind you that if I'm multiplying by 0.07 to figure out how much it's depreciating, that means, so 7% it's depreciating, so that means that the real value is 93% instead. So think about that. It's like when you buy something that's on sale. If it's on sale for 20% off, you're still paying 80% for that item. So this car is still worth 93% of its value the prior year. So my multiplier is not 0.07. That would mean the car was worth hardly anything, but rather 0.93, like this. And that should make sense if you look at the table. If I put 0 for the exponent, anything to the power of 0 equals 1. So 0.93 to the 0 power equals 1. 1 times 20,000 is 20,000. So my equation matches my table. So I've got my sequence, I've got my table, my equation. Now I just need to draw a graph. Now, this graph isn't going to look the greatest because these values are so high. So I can put value of the car over here and time in years. And for my value, I am going to have to go by, let's see, 3,000. So I'll just put thousands there. So 3, 6, 9, 12, 15, 18, 21. We'll see how this graph turns out. It's not going to look the greatest because these numbers are so high. You could do a gap in your graph if you wanted to, and that would make your graph look a little bit better. Yeah, a gap would definitely make this look better. You can see that it's curving, but because my values in my y-axis are so close together, I didn't have enough room. If you put in a gap, and then just went up by thousands each time, you would get a better result. All right, question number 2. Cottage Grove's population is currently 35,000. The annual growth rate is 3%. Make a sequence, table, graph, and equation to represent this situation. And approximately what will be the town's population in 7 years? So now not only are we doing the sequence, table, graph, and equation, but then we're going to use that information to answer a question. So our sequence, table, equation, and then we'll need a graph. This one I'll put in a gap, so hopefully it will look better for you. So, this one is increasing. So what happens when something is increasing is a little bit different. So we're starting with 35,000. It's increasing by 3%, so I still use a multiplier. This multiplier is 0.03. It's increasing 3%. So the difference from the last problem to this one is that when I figure out how much it's increasing, I have to add that on. So now, instead of subtracting, my second value is 36,050. So 36, so 35,000 starting, I'm going to do these at the same time, 3650, okay, then I multiply that by 0.03, and I get 1081.5, which I'm going to round up to 1082 because you can't have half of a person. So my next value is 37,132. Multiply that again. I get 1113.96, so 1114. Which gives me 38,246. 38,246. And I could continue this. I ran out of room on my sequence up here, so I'll put my commas in for my sequence. But I can continue this one for one more for my table. $1147 is the next increase. So 39,393. Okay. Now my equation this time. My equation's a little bit trickier. F of x equals, the starting value is 35,000. Now, because I am multiplying by 0.03 and then adding it on, my multiplier is actually 1.03 because it's more than the initial population. So if I multiply 35,000 by 1, that gives me the 35,000. And then if I multiply it by the 0.03, it gives me that 3% that's added on. So the last problem was something that was decreasing, so it was less than 1 for the multiplier. This one, because it's growth, it's increasing, it's more than 1 for our multiplier. Now we are ready to make our graph, and then we will answer that question. So my graph, so this is population of Cottage Grove. And I'm going to put thousands up here. And we're going to see if this is going to look better by throwing a gap in. All right, so this can be time in years. And this is population in thousands. All right, let's see if this looks any better. 35,000, 36,050, 37,132, 38,000, and then 39. Well, this one should be curving, so I'm going to make it curve. It almost looks like it's linear, which is definitely not what it is. So on this one, because I went by a scale of 1, maybe that was too small of a scale. Not sure. But I know that when a graph is exponential, it always has to have a curve to it. So this is not linear. It's not going up exactly the same amount each time. It's going up a little bit more each time. If you look at our values up here, you see it's not linear. If it's linear, that increase has to be exactly the same. So because it was 3%, it's close. Our next and final example, make a sequence table graph an equation to represent this situation. The half-life of a certain material is 0.002 seconds. Oh, sorry about that. I forgot to answer the question at the bottom. Approximately what will be the town's population in 7 years? In 7 years, I think the easiest way to answer this question is to use our equation and plug in 7. So if you plug in 7 for x, 35,000 times 1.07, 1.03 to the 7th power equals 43,046 people. So in 7 years, you plug in 7 into your equation and then solve it. Okay, back to the half-life. So we need a sequence, table, graph, and equation, and then we have a question to answer again. So the half-life of a certain material is 0.002 seconds. Approximately how much of a 12-gram sample will be left after 0.008 seconds? I'm going to start this one with a table. Then we'll have our equation. Then we'll go to the sequence and the graph. It really doesn't matter what order you do any of these in. All right, so my table the material starts with 12 grams. 12 grams. Then half-life means that after a certain period, it's cut in half. So if I cut this in half, I would have 6, and then I would have 3 left, and then 1.5, and then 0.75. So the amount of this sample is cut in half. Now, on the X side, I want to remind you that at one half-life period, that would be 0.002 seconds. So then another half-life period would mean 0.004, so it's 4 thousandths. So then the next half-life period would be at 8 thousandths. Oops, sorry about that. Oops. Fix that one for you. Okay, so every 2,000, so not 8, it's not multiplied by 2, but 6, and then 8. Okay, there we go. So our sequence is going to be 12, 6, 3, 1.5, 0.75. This sequence is a lot easier to write than the last few. Our equation, f of x equals, starts with 12, and it's a half-life, so it's cut in half each time. So it's multiplied by half to the power of x. So notice in my table, I didn't use the 0.002 seconds in the table. I used half-life periods instead. So every 2,000ths of a second, it was cut in half. I just counted those periods of time. So my graph, this graph will look better than the others because it has smaller numbers. So this can be half-life periods. So half-life periods and amount left. And this is grams. Okay, so hopefully this one gives us a better look at the curve. So at 0 half-life periods, the amount left is 12. Then it drops to 6. Then it drops to 3, 1.5, and 0.75. Beautiful. Finally, a graph that shows us the exponential curve that we're looking for. Okay, so if I scroll back up, we've got the sequence, we've got the table, the graph, the equation. So now we have to answer the question. After 0.008 seconds, you can see in my table, the answer would be 0.75 grams. If they're asking you a question where the answer doesn't appear in your table, you have a lot of options. You can continue your table if you wanted to, or you could use your equation. Using your equation, though, remember you would not plug in 0.008. You would have to figure out how many half-life periods that is. So the half-life periods, you would just take this value and divide by the amount in each half-life period to see. So if I divided those, I would get 4. So that would be my 4th half-life period. All right, you should be able to write a summary now, answering your essential question. Make sure that you restate that essential question and fully explain how you do what that EQ is asking.